Numpy array slicing. We know that slicing means taking elements from one given index to another given index and to slice a given array we use this start index and end. Here again the start index is included in result. It is includes in our result, but it is excludes in our result, excludes from our result. Okay, for example, if we import here, import numpy as np and take here a is equal to np dot array, say 1 2 3 4 5 6, and if we print here, say starting index from 2 to say 5, then the starting index is 2. It includes in our result, but this is what excludes from our result. Okay, so it prints from index 2 3 and 4. So index 2 3 4 means this is index 0, this is index 1, and index 2, index 3, index 4 and index 5. So it prints elements 3 4 and 5. It prints elements 3 4 5. You can check also here, import numpy as np and take an array a is equal to np dot array, okay, say 1 2 3 4 5 6, okay, 7 5 6 only. And if we use command here, print 2 to 5, yes, I am checking here, 2 to 5, okay, then it prints a dot 2 to 5, it prints 3 4 5. You can check here, it prints what, 3 4 5. One more, we take one more array, say here a is equal to, take one more array, np dot array from 1 2 3 4 5 6 7 8 9 and 10. Okay, so here this is a 0 index, 0 1 2, default our array start from 0 3 4 5 6 7 8 and 9. So if you print here, print from a from 0 index to say 6, then it print, since last index exclude means what, it prints from 0 to 5, index 0 to 5. So 0 to 5 means what, it prints 1 2 3 4 1 2 3 4 sorry 5 up to 5, 0 1 2 3 4 up to 5. So it is print 6 up to 1 2 3 4 5 and 6 elements. Suppose here 6 7 8 9 and 10, and if you use command from a is equal to 0 to 6, then it prints 1 2 3 4 5 6. You can check here, 1 2 3 4 5 6. Now if you don't pass a starting index, then it consider as 0. That is, if you don't pass your starting index, that is here, if you just only print a double colon and okay, and here say end, okay, then default it consider the starting index is what? Starting index is 0. That is here in the same example, suppose it is given array A. Again, if we consider an NP array, A is equal to NP array is equal to 1 2 3 4 5 6 7 8 9 10. Okay, and if you don't pass an starting index, print A, and if you just print the end index, say it is say 5, then it prints from this is 0 1 2 3 and 4. Since last end index excludes, this excludes, so it prints up to 4. You can check here, so 0 1 2 9, and if you don't pass the starting index, just if you provide end index, then you can check, you print it prints 1 2 3 4 5. You can check here 1 2 3 4 and 5. It prints this many elements 1 2 3 4 and 5. Similarly, if you don't pass end index, suppose if you don't pass end index, say it is say start, okay, and if you don't pass then it consider as length of array, it consider as length of array dimension, length of array in that dimension, array in that dimension. So here, what is the length of this array dimension? 1 2 3 4 5 6 7 8 9 and 10. So it consider the length of in that array dimension. So for example, if you consider an example, say here a is equal to np dot array, and if you consider here 1 2 3 4 5 6, okay, 7 8 9 and 10, then we know that this is 0 index, this is 1, this is 2, this is 3, this is 4 5 6 7 8 and 9. Here length of this index, length of a is equal to 10. So if you just print here, print from starting say here if you use the starting index, say 4 and no end index, then it consider as 4 10. Since what is the length of the index? 10. Since last index is excluded, it prints from 4 to 9. So it print an elements from 5 to 10. You can check here, if you pass here 4 starting index but not end index, then in that case here what is it considered? It is 5 6 7 8 9 and 10. You can check here 5 6 7 8 9 and 10. You can also, okay, if you just pass not starting index and not end index, then it prints entire array. It prints entire array. If you just print here, it prints total array. Okay, you can also print here prints the entire array. Now next if you want to, you can also print a step. For example, if you consider here, for to print a step, use start double colon end and your step. Okay, so for example, if you consider a is equal to np dot array, and if you consider an array, say 1 2 3 4 5 6 7 8 9 10, okay, we know that this is index 0, this is index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8, and index 9, and if you print here, print from a from 1 to 8 with step function 2. If you don't pass a step, then it default it consider as a 1. Here default it consider as 1. So we are going to print elements from 1 to 7, this many element, but with step 2, that is first element is 2, then second element is what, 4. Since step is 2, we want to skip one element, 6, and then 8. So our output will be generated as 2, 4, 6 and 8. You can check here, if we pass a dot a, starting index as 1, okay, end index as 8 with step function as 2, and if you clear the previous output and if you pass here, you can check here, it is 2, 4, 6 and 8, 2, 4, 6 and 8. Okay. Again, if you don't pass here, if you don't pass starting index and end index, and if you just print here 2, it will print, okay, it will start from 0 to last element, length of the array of the dimension, and print from it skip one element. Okay, so here 1, 3, 5, 7 and 9, that is, if we print here a is equal to, say, print a, not starting index, not end index, only step function is 2, then from this element it start from index 0 and index 9, it prints from index 0 to index 9, but with step function step 2. So it is 1, 3, 5, 7, 9. Okay, if you say here instead of 2, if you consider here 3, then from it is, suppose our array is what, np.array is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And since we want to print step 3, so the first element is 1, then skip 2 elements, then it prints 4, then skip 2 elements, then it prints 7, then skip 2 elements, and then it prints 10. So it prints, output will be as 1, 4, 7 and 10. So you can check here, if you don't pass start index, end index and 3, then output will be, you can check, output is what, 1, 4, 7 and 10. Check here, 1, 4, 7 and 10. Okay. So this way you can slice and index. Okay, you can also slice a negative index, that is, suppose here a is given np.array, a is equal to say here, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. We know that this is for negative index, it is -1, -2, -3, -4, -5, -6, -7, -8, okay, -9 and -10. So if you use the print from a from -10 to here -1, it is 0, okay, 0, because starting since we exclude the last index, then it prints the entire array. You can check here, if you use the slicing as, suppose -10 to first, if you use -1, then it prints 1 2 3 4 5 6 7 8 9 minus 1, that is minus 1 minus 1, it is what, minus 2. So if you use here a minus 10, if you slicing minus 1, then since it exclude the end index, so minus 1 it is what, minus 2. So it prints 1 2 3 up to 9. Now if you use here 0, then you can check, sorry, okay, you cannot use your 0 as index, okay, so you cannot print the last index here. So now to print, you can use here, okay, instead of minus 1 you can use minus, say use minus 4 to minus say 6, then minus 9, then it prints, then here it prints minus what, minus 4 to minus 9 means what, minus 4 to minus 9, it prints from 2 to 7, just sorry, here minus 9 to minus 4, minus 9 to minus 4, okay. So it is what, 2 3 4 6 up to 6, 2 3 4 6, you can check here. So minus 9 to minus 4, 2, since it exclude the last index, so it is only you can print minus 9 to minus 4, so my 2 3 4 5 6, since last index is what, excluded. You cannot print the last 10 here in slicing, because if you use here say minus 1, then, and what happened here, it prints up to 9, but if you use here 0, then it gives an empty array, okay. So you cannot if you want to print, if you use this, okay, if you want to print and last element, just don't pass last index, so it prints 2 3 4 7 8 and 9, it prints last element also. So if we consider here say minus 10, then it prints entire array, you can check here 1 2 3 4 5 6 7 8 9 and 10, it prints an entire array, okay. So this way you can use a slicing. Numpy is Python package and it stands for numerical Python. And which is used to create a n-dimensional array object in the form of rows and columns. Now to create a n-dimensional array, we use the function array, and we pass a list or tuple to create an array. For example, so first we want to import a library numpy, so import numpy as np and take the first data 1 is equal to np dot array and pass a list, say 1 2 3. Now it form a one-dimensional array. Similarly, to create, if you print, you get one-dimensional array. For example, here if we import here, import import numpy as np, and if you write here np dot array 1 2 3, okay, then you will get it is what, one dimensional array. Or here also you can write this as import. In a programmer also you can write numpy as np and data1 is equal to np dot array and array say 1 2 3, and if you print data1, you will get an array, one dimensional array 1 2 3. Now you can perform many arithmetic operation on this array. For example, if you multiply here multiply 2 into data1, it perform element wise multiplication. So you can see here we multiply each element of this array by 2, so output is what, 2 4 6. Similarly you can add also 2 plus data1. If you can see here we add 2 in each element of this array, so output is 3 4 and 5. Similarly you can subtract also 2 minus data1. You can see here 2 minus 1 is 1, 2 minus 2 is 0, and 2 minus 3 is what, minus 1. You can also take power here raised to, say, raised to 2. If we take raised to 2, it is what, 1 2 3. So 1 raised to 2 is 1, 2 raised to 2 is 4, 3 raised to 2 is what, 9. You can also divide each element by, say, 10. So if you divide by 10, then output generated will be, you can see it is 0.1 0.2 0.3. So this is what you can perform many arithmetic operation on this array. Also you can write here data, you can add here data1 plus data1, so it perform element wise addition. So data1 plus data1, it is what, 1 2 3, and we add 1 2 3 again, so it is output is what, 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is what, 6. You can multiply element wise also, data1 into data1, output is what, 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is what, 9. So you can perform data1 minus data1 also. So the output is what, 1 minus 1 0, 2 minus 2 0, 3 minus 3 0. So you can perform so this is the application of array. Again you can determine the dimension of array also. So now to print dimension of this array, just this function n dimension returns dimension of array. So we can create one dimension, two dimension array. For example, here if we write data1 is equal to np dot array, and if you pass only single list, say 1 2 3, and if you write here data1 dot n dimension, if you print this, the output will be 1. You can create a two dimension array also by using nested list. So data1 is equal to np dot array. Now to create a two dimension array, this is the first list 1 2 3, this is the second list 4 5 6, and enclose these two lists in one more array, one more close bracket, and now this is what two dimensional array. Now if you print data1 dot n dimension, the dimension of this array is what, 2. So you can check here, suppose here data1, and if we print here print dimension equal to dimension is equal to data1 dot dimension n dimension. Now if you run, you can see here the dimension of this array is equal to what? 1. Now to create two-dimensional array, use the nested list. So I am creating here one more list, say 4 6 7. Okay, and if you run this, it is what the dimension, this is what two-dimension array. Now you can create one more dimension by using nested list. So to create one more dimension, what you want to do here, you can create a three-dimensional array. Suppose this is what data1 is equal to. So this is the first list, 1 2 3 4 5 6 and 7 8 9. Okay, so now by using this is what three-dimensional array, and the dimension is equal to what? 3. So if we write here, or if you print this 1 2 1 2. Okay. Now if you run, what is dimension here? 4. Sorry, if you remove one more bracket, dimension is what? Dimension is 3. The dimension of this, it is equal to what? 3. You can use here one more, say 6 say 8 9 10, then 8 9 10. Sorry, dimension is equal to what? 3. Also if you again consider one-dimensional array or two-dimensional array here, say, and if you now to create two-dimensional array, the element should be same. If this list contain 3 elements and this list contain 2 elements, and if you try to convert it into an array, you will get an error. It is what? An error, because the here element are not same. So if you write here 7, then you can see here it is what? Two-dimensional array, and dimension is equal to what? 2. So this way you can create a empty list also, empty array also. So here, what is the dimension of this array? It is equal to 1. Dimension, empty list dimension is 1. Here also you can create, it is what? Dimension is 2. If you add one more square bracket, then dimension is equal to what? 3. And if you just pass just one element, say 4, then say here dimension is 0. What is dimension? 0. There is we pass just one element here, and the dimension is equal to what? 0. Now next shape. The shape function returns the shape of array. It returns shape of array. So for example, if we consider this array, say 1 2 3. Now what is the shape of this array? Since it contains this list contains 3 elements and there is nothing next, so the shape of this array is 3 into 1. So here if we write, this is 1 2 3, and if you print here, print shape of this array is data1 dot shape, then you can check, it returns tuple and the shape is what? 3 1. But if you add here one more nested list, So here say 5 6 7. Then what is the shape here? This list, okay, I am going to explain here. Suppose if you consider a nested list, 1 2 3 and 4 5 6. So this list contain two elements, so the 2, and this inside this list it contain total 3 elements. So the shape of this array is equal to what? 2 into 3. If you print here, you can say the shape is equal to what? 2 into 3. If you consider one more nested array, say 1 2, then 2 3, okay, and 4 6, okay. Now, and if you print the shape of this array, then how many elements in first list? There are 0 1 and 2, that is 3 elements are there. So 3 into, and the second list contain elements is 2. So the shape of this array is equal to 3 by 2. So if you consider here, it is equal to 1 2, then say 4 5 and 6 7, then the shape is equal to what? 3 by 2. You can check here, it is 3 by 2. If you consider one more example, say here 1 2 3 and 1 2 3, sorry, 4 5 6. Okay, now the first list contain how many elements? 2 elements. Okay, this is one element and this is second element, and the list contain the nested list contain 3 elements. So the shape of this array is equal to 2 by 3. Okay, so if you consider one more example, say 1 2, then 4 5, okay, and see here, this list contain, okay. Now this inside list contain 2 element, this list contain, okay, this list contain 2 elements, so 2 2, and if we add here, so you can check a dimension here, say you want to enter here 1 2 and 4 5, and now 1 2 3, and you can, now if you run, what is dimension here? 1 2 2. So here this list contain, okay, I am explaining here 1 2 2. If you consider here first 1 2 and 3 4, so this list contain one element, so 1. The second list contain 2 element, so 2, and this the list contain the last nested list contain elements 2. So the shape of this array is equal to 1 2 2. Okay, now if you consider here, take one more example, say 1 2 3 4 5 and say 6 7 8 9. So what is the shape of this array? Now this list contain 2 elements, so the 2, and the inside list, then list contain 4 elements, so order is shape is what? 2 by 4. You can check, it is what? 2 by 4. But if you add one more array here, then one more dimension here, then it is what, 1 2 4, 1 2 4. So this list contain one element, okay, then this list contain two elements, and the inside list contain four elements. So the dimension, so the shape of this array is 1 2 4. There is new function arrange, okay. This is again, it creates a new array, that is, it is an array of evenly spaced values in given interval. So if we write here, say if you write here np.arrange say 5, then you can get evenly spaced value from 0, start from 0 to 4, okay, evenly spaced array. If you change here elements, say 7, then you get even array of evenly spaced value from 0 to 6. Next, there is one more function called a reshape. Now it creates a new shape to an array without changing its data, So if you want to create, say, 2 by 3 array, then total element will require 6. So data 1 is equal to np arrange, say, 6 element, and print. Suppose you print data 1 dot reshape, say 2 by 3, okay, 2 by 3, then we get the array of the shape 2 by 3. So if you write here np.arrange 6, and if you write print data 1 dot reshape shape 2 by 3, so now you can check. It is what, a 2 by 3 two-dimensional array containing how many elements? 3 elements, okay, 0 1 2 3 3 4 5 6, one extra bracket, want to remove that. So now if we check 0 1 2, but if you pass your 6 7, then it is not possible. There is an array, there is an error. Why? Because we require total how many elements? 6 elements. Here there are 7 elements. So if you want to create, say, 3 by you can also create 3 by 2 shape array, 6 element want to arrange. So you can check here what is the shape of this array. 3 by 2, or it contains 3 rows and 2 columns. So you can create any shape of array. So if you pass here 12, then you can create 3 by 4 shape array. So it is what, 3 by 4. So 3 rows are there, 0 1 2 3 4 5 6 7, 8, 9, 10, 11. No, how many columns are there? 4 columns are there. So it is what? 3 by 4. Now the next new array is like arrange. It create an array of evenly spaced values in a given interval. The next new array is in zeros. Now this function create a new array of given shape with zeros. New array of given shape with zeros. For example, if we write here, say np dot zeros 3, then it create new array with given shape, and that is 3 by 3 shape with zeros. So if we write here, data 1 is equal to np dot zeros 3, then it creates, and if you print data 1, then you can see here, it creates a 0 with shape is what? 3. If you write here 3 by 2, then it creates a 0. I want to use one more bracket here, 3 by 2. Now you can see here the shape of this array is what? 3 by 2. So the first this array contains 3 elements, and the inside array contains 2 elements. So shape is what? 3 by 2, or it contains 3 rows and 2 columns. Next, if we pass here 4 by 3, it also create a shape of array with shape 4 by 3 with all the entries is equal to what? 0. Similarly, you can create there is one more new array, that is ones, same as zeros. It is a new array of given shape with ones. With what? Ones. So if you, instead of zeros, if you write here ones, then you can check here what is the shape of this array? 4 by 3, and all the entries is equal to what? 1. If you pass here only single entry, says 5, then it contain a 5 single array with a single dimension array with entries equal to what? 5. If you write here 2 by 5, then it is what? 2-dimensional array with all the entries equal to what? 1. So this is all about the ones. Now the next indexing and slicing. The next topic is indexing and slicing. So if you consider an array, say here data 1 is equal to np dot array, say here 1 2 3. This is a one-dimensional array. The index of this first element is 0 1 2. So if you print here, print data 1, okay, and if you pass index here, say 1, then it prints an element 2. So if you consider here data 1 is equal to np dot array say 1 2 3, and if you print data 1 dot data 1 index is what? 1, then Okay, it prints what? 2. It prints 2. So what is the index of this element is what? 2. If you consider, say here 6, 7, 8, 9, and if you print here, take one more element, 10, 11, 12, and if you print here, say data 1 dot 4, then this is the 0 index, 1, 2, 3, 4. So output is what? 10. Output is what? 10. You can check here. So this way you can access an element from array by using its index number. Okay, if you pass here 0, then it prints the first element, that is 6. It prints the first element 6. Now next you can slice also. So slicing, we know that to slice you can pass the start index and end index, start and end, but here starting index is inclusive, and it is what? Exclusive index. That is, if you print data 1, okay, print data 1 and print data 1, say starting index say 2 and end index is say 6, then it print an element, say here data 1 is equal to 1, 2, 3, 4, 5, 6, 7. Okay, so this is the 0 index, this is 1 index, this is 2 index, this is 3 index, 4, 5 and 6. So it 2, so it prints 3, then 4 is included, and 4 and 5, so it prints 3 4 then 5. Okay, 2 3 4, sorry, add 2, it is element is what? 3, so it prints 3. Then next at 3 it is 4, and next at 4 it is 5, so 5 and then 6. So if you use a slicing here, say slicing is 2 to 5, then it prints how many elements? It slice, okay, 2, so this is 0, 1, 2, so it prints 8, then 9, so 2, 3 up to 4, since it is last index is last is what? Index is exclusive, so it prints 8, 9 and 10. You can check here 8, 9 and 10. So this way you can do a slicing. So if you take one more example here, data 1 is equal to say 1, 2, 3, 4, 5, 6. It is an array. Data 1 is equal to, sorry, data 1 is equal to np dot array. This is same as list. Slicing works same as list. Say 1, 2, 3, 4, 5, 6, 7, 8, and if you print, say print data 1, say, okay, not starting index, just only end index, say 4, okay, then it prints up to 4. This is 0, this is 1, 2, 3, 4, 5, 6, 7. So here this G up to 3, because last index is what? Excluded, so it prints 1, 2, 3, 4. It prints 1, 2, 3, 4. So in the given example, if you here 6, 7, 8, 9, if you want to print 6, 7, 8, 9, then what is the index here? This is 0, 1, 2, 3. So we want to pass up to 4. to 4. So now we get up to 3 index, so it is 0 1 2 3 elements up to 3 index. So you can check here 6 7 8 9 up to 9. Okay, similarly if you pass just no start index, no end index, it prints the total array. Then if you write here say 4, then this is 0 1 2 3 4. So since it is included 4 10 11 12, it prints 10 11 12. But if you pass here 4 2 6, then it prints only 10 11. It prints only 10 11. So this is all about the slicing. Negative slicing is also possible. If you write here say -3 to -1, this is a -1 -1 -2 and -3. So sorry, -1 is since it is excluded, again this index is excluded, so it prints -2 and -1, -2 and -3. So it is what 10 11. If you want to print the last index, then just remove this and last element, then you get 10 11 12, 10 11 12. You can use, so negative indexing is also possible. Now the next topic, you can find some linear algebra operation you can perform on this array. The first linear algebra operation is transpose of array. Suppose you want to transpose, so say given array is n, data 1 is equal to np dot array say 1 2 3 4 5 6, and if you print this, you will get 1 2 3 4 5 6. But if you use here array, that is data 1 dot t, this will, if you print data 1 dot t, it prints the transpose of the array. So if you consider here data 1 is equal to, consider two-dimensional array containing 3 elements, so 1 2 3 5 6 7. So now if you print here, print data 1, then you can check it is what 1 2 3. What is the shape of this array? The first list contain 2 elements, so its shape is 2 by 3. What is shape? Here print shape is equal to 2 by 3 data 1 dot shape. So the shape is equal to 2 by 3. But now if you transpose this, say data 2 is equal to data 1 dot t, and if you print data 2, or you can write here transpose of array equal to, so you can perform matrix operation here data 2. Now you can check it is what the original matrix is what 2 by 3. The shape of the original array is what 2 by 3. Now the new shape is what, again the list contain 3 elements, so it is 3, and the last list contain 2 elements, so it is 3 by 2. What is the shape here? If you print this again here, data 2 dot shape. So what is the shape of the original array? It is 2 by 3. and the new array is what, 3 by 2. Okay, so this way you can find a transpose of the given shape, given array. Now the next operation is you can also obtain the inverse of the matrix. Some linear algebra operation you can perform. Numpy statistical function. Consider an example. Say data 1 is equal to np dot array. Say 1 2 3 4 5 6 and 7 8 9. So what is the shape of this array? This is 3 by 3. 3 by 3. This is 0 1. This inside list contain 3 elements, and again the array contain 3 elements. So the shape of this matrix, or you can say it is 3 by 3 matrix. So first we want to determine mean of this matrix. Then you can just enter the command mean data 1 dot mean. Okay, then you will get the mean of this array. Or there is one more method. If you enter the np dot mean array data 1, you will get a mean of the given data. What is the mean? Mean is nothing but the sum of elements divided by number of elements. In this way we can find a sum of this matrix. So what is the sum here? 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. This divided by 9. So this is equal to, if you try to find this mean in Python, then okay, so first we want to import numpy. So import numpy as np. Now define array. Here data 1 is equal to np dot array. Array is the function we can pass a tuple or list to create an array. So say 1 2 3, then next 4 5 6 7 8 9, 7 8 9. Okay, and if you print data 1, we get and this array matrix. Okay, so what is the shape of this? If you print data 1 dot shape, then the shape of this matrix is equal to shape only. The shape of this matrix is what? 3 by 3. So now we want to determine mean. So print data 1 dot mean. By using this inbuilt function, you can find mean of these elements, mean of this matrix. It is nothing but the 1 plus 2 plus 3, 4 plus 5 plus 6, 7 plus 8 plus 9. It is what? 5.0. In other words, you can also find a mean by using print np dot mean data 1. So it is equal to, this way you can also find this is mean by using this function data1 dot mean, and this mean we obtain by using np dot mean data1. Similarly, if you want to determine median, then just enter here mean. Instead here mean, just enter median. You will get the median is equal to here, median is equal to median is what, 5.0. so these are some standard inbuilt function. Again you can find sum, sum you can find. So to find a sum, just if you enter here sum, print sum is equal to data1 dot sum. You will get the sum of each element of this matrix, so it is equal to what, 45. Sum of this matrix is equal to what, 45. Now next you can also obtain sum by axis 0 and axis 1. So what is axis 0 and axis 1? The axis 1 is a vertical axis, or in other words you can say columns. So here if this is the matrix given, say 1 2 3 4 5 6 7 8 9. So if you find a sum, say data1 dot sum along the axis 1, then it determines the sum, it is equal to 1 plus 4 5 plus 17, it is 12. So output is what, 12. Then 2 plus 5 7 plus 8 15, and here 3 plus 9 12 plus 6 is what, 18. So if you find a sum along the axis 1, so here I am writing median, here I am writing mean. Print sum, vertical sum, or you can say column sum is equal to data1 dot sum axis equal to 1. So now if you use this command and if you print, you will get what is sum. Sum is sum is equal to 6. This axis 1 is the sum of, this is axis 0, axis 0 not axis 1, axis 0. Here also want to change axis 0. This is sum along axis 0. Axis 0 determines the sum of columns, and axis 1 determines sum of rows. So axis 0 is equal to what? Here the sum is equal to 1 plus 2 3, 3 plus 3 6, then 4 plus 5 9, 9 plus 6 15, 9 plus 7 16, 16 plus 8 24. So this way we can find a sum. So it is equal to it is 6 15 24. If you write here axis 1, then it determines the sum of rows. Axis 0, if you find here axis 0, it is equal to, it is what, 12 15 18. So axis 0 determine the sum of columns. This is what, sum of columns, that is 1 plus 4 plus 7. You can check here. Sum axis 0 is what, 12 15 18. And if you write here axis 1, print the row sum is equal to row wise sum. You can say row wise sum is data 1 dot sum axis 0 then here it is axis 1 we get it is what row sum is 6 15 24 and column sum is what 12 15 18. So here I am explaining it again. Suppose this is the given matrix, say 1 2 3 4 5 6 7 8 9, and if you want to determine column sum, okay, then just write this column sum can be determined by using axis 0 and row sum can be calculated by using axis 1. So similarly you can also find a mean of axis 1 and axis 0. So for example, if we take the same example here and if we write here data 1 is equal to 1 2 3 4 5 6 7 8 9, and if you write here the mean data 1 dot mean axis equal to 0, then axis 0 determine the mean of columns. So here what is the mean of this column? It is 1 plus 4 plus 7 divided by 3, then 2 plus 5 plus 8 divided by 3, and 3 plus 6 plus 9 divided by 3. So it is equal to 1 plus 4 5, 5 plus 7 12 divided by 3, so it is 4, then 2 plus 5 7 plus 18 15 divided by 3 is 5, 9 plus 18 divided by 6, so it is what 4 5 6. So if you write axis 0 here, if you write data 1 mean axis 0, you will get 4 5 6. You can check here, it is what 4 5 6. And if you write here axis 1 for the same matrix, say here if you write a matrix is equal to data 1 is equal to say 1 2 3 4 5 6 7 8 9, and if you find data 1 dot mean along the axis equal to 1, then it determines the sum mean along the horizontal axis. Okay, this is what our row it determines it is what horizontal axis. So what is the horizontal axis here? 1 plus 2 plus 3 divided by 3, 4 plus 5 plus 6 divided by 3, 7 plus 8 plus 9 divided by 3. So this is equal to 6 divided by 3, it is 2. Then here 4 plus 6 10 plus 5 15 divided by 3, it is 5. 7 plus 9, it is 7 plus 9 16 plus 8 24 divided by 3 is what 8. So if you write here not sum, it is mean or average. So axis 1, it is what it determine a row wise mean, then it is equal to what you can check here 258. It is what 258. So this way you can find mean and row along the horizontal axis and vertical axis. Now the next topic is we can generate a random matrix by using this can generate a random matrix. Suppose to generate a random matrix, we want to import from Numpy numpy dot random import rand n. Okay, and if you write here data 1 is equal to rand n of say order 4 by 4, this shape matrix you can generate. What is this function? It takes the what standard normal distribution value, that is standard normal distribution, that is values lie between 0 and 1, and it generates a 4 by 4 matrix. So here if we write from numpy dot random import rand and n, and if we write here data 1 is equal to say rand n, say all the shape of this matrix is what 4 by 4, and if you print data 1 you will get a random matrix of order 4 by 4. Okay, it is what 4 by 4 matrix. Then next, from this you can generate any shape. You can here 4 by 3 also you can generate. You can generate say 2 by 2 or 3 by 3. You can generate 3 by 3 matrix. Okay. Now you can also find this the sum print data 1 dot sum. Here you can also find it the sum. What is the sum here? Minus 5.91169364. You can also find average here, mean. So print data 1 dot mean. You will get the here the first is what the sum, this is what the mean. Since every time it generates a new random matrix, so every time this sum and mean changes. If you run this one more times, you can check here the mean and sum get changed here. So now next you can replace. There is one more important function where by using this where function you can replace the positive value by some fixed number and negative value by some fixed number. That is, suppose here if we generate a random matrix, and if you want to replace all negative value by 5 and positive value by 6, then just write down here print np dot where, by using this function where data 1 greater than 0, if this is true then replace by 5, otherwise else replace by minus 5. So if you use this, you can check data 1 np dot where data 1 greater than 0, what is np is not defined. Okay, we want to import numpy as np. So you can check here for this negative value we replace by minus 5, for this negative value we replace by minus 5. Since it is a positive value we replace it by 5, since again here it is positive we replace by 5. So this way you can replace the positive value by some fixed value and negative value by some fixed value. Next you can also find positive sum. So how many elements from this these are positive, by using here, if you write here, print data 1 greater than 0, how many dot sum. By using this function you can find how many elements are positive here. So, beta 1 though which are greater than 0, beta 1 greater than 0, so 5 want to print this matrix also, so print data 1. So if you print here, sorry, you can check here how many elements are positive. This is negative, 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 but 1, 2, 3, 4, 5 and 6 elements from this matrix are positive. So by using this condition you can check how many elements are positive, and if you write here less than 0, then again it will generate the random matrix 2 elements are negative. Okay, so thank you. Python Numpy linear algebra. First we are going to solve and system of linear equation using Numpy array. Suppose we want to solve and a system of linear equations is twice x plus y plus z is equal to 5. Then next equation is x plus 2y plus z is equal to 6, x plus y plus twice z is equal to 7. Then first of all we write the given system in matrix form as Ax is equal to b, Ax is equal to b. So if we write this system into a matrix form, we get 2 1 1 1 2 1 1 1 2 into x y z equal to 5 6 7. And then you can apply various techniques to solve or to find a value of x y z. The first technique is, if this is a non-singular matrix, then that is determinant is not equal to 0, then you can apply x is equal to a inverse b technique, or you can reduce this matrix to a row echelon form, or that is you can apply a Gauss elimination method or Gauss-Jordan elimination method. Now since we are going to use a Python here, so if you apply a solve AB, you will get the list of solution or containing the value of x, y, z in Python. For example, if we first of all want to import numpy as np, and then from numpy dot want to import the linear algebra file. So numpy dot linear algebra file. Okay, from numpy dot linear algebra import all the standard function. So for star, then we want to write a matrix A. So what is the A here? A is equal to 2 1 1 1 2 1 1 1 2. So A is equal to np dot array. Since we pass the for this array function, we are going to pass here list having shape 3 by 3. So here 1 it is what 2 1 1 2 1 1. Then next is 1 2 1, and next is 1 1 2. Next we want to write the b, which is equal to again np dot array, and it is equal to what is the b here? Matrix B is 5 6 7. Matrix B is 5 6 7. Now here we are going to use, if you write here print solve AB you will get the list of solution containing the value of x, y, z. So here the 0.5 is x, solution of x, that is x is 1 by 2, here 3 by 2, and this is 5 by 2. Okay, so that is x is 0.5, y is 1.5, z is 2.5. You can also write this as, if you write here x, instead of print, if you write here x, y, z equal to solve AB, then the and if you write here print x is equal to x, next y is equal to, see here we want some space, okay, then next y is equal to y, and z is equal to z. Then we get the value of, this is x, y, and z. You can check here, this is what x, y, z. X is 0.499, that is it is 0.5, y is 1.5, z is what, 2.5. so this is what x, y, z. So you can apply, if it is a singular matrix, you will get some error, that is if it has a given system has infinitely many solutions, that is if you write the matrix, say suppose you write a system of equation twice x plus twice y equal to 4 and x plus y is equal to say 8. Now this system has infinitely many solutions. Okay, two, here, right here 2, x plus y is equal to. So this system has infinitely many solutions, that is if we write a matrix A here 2 2 1 1, this matrix is what, singular matrix, since its determinant is 0. The determinant is 0, that is if you evaluate this determinant here, this is equal to what, 2 minus 2 is equal to 0, and such a equation if you write in Python, it may give an error, that is if you want to apply this solve command, then there is an error, that is first if you write here 2, then here the next row is 1, and here if you write 4 2, and if you write here print solve AB, print solve AB, solve AB, then you can see here the matrix is what, singular matrix error. This is what, singular matrix, because the determinant of this matrix is what, 0. Now to evaluate a determinant, you just write here, suppose you want to evaluate the determinant of this matrix, say this is the A matrix, A is equal to 2 1 1, A is equal to, say here 2 1 1, 1 2 1, and 1 1 2. Now we know that to evaluate the value of this determinant is equal to the value of this matrix, the determinant of A is equal to 2 times 2 1 1 2 minus 1 times 1 1 1 2 plus 1 times 1 2 1 1, that is 2 times the determinant of this here, this determinant of this 2 by 2 matrix, then for minus 1 we take 1 1 1 2, and for 1 we take this determinant, 2 by 2 determinant. So this is equal to 2 times 4 minus 1 times 2 minus 1 plus 1 times 1 minus 2. So if you try to evaluate this, we get 2 times 3 minus 1, 2 minus 1 is 1, plus 1 times 1 minus 2 is minus 1. So this is 6 minus 1 minus 1. So this is equal to 4. So the value of the determinant is equal to 4. Now to evaluate this determinant in Python, you just write here A is equal to, okay, right, here we are going to write create a matrix using numpy array. So array np array 2 1 1, then 1 2 1, and then 1 1 2. And if we want to evaluate the determinant of this matrix, then just write down here print determinant of A. So if you write here, you get sorry, what the missing, where does not closing parenthesis not matching. Okay, here is an error. So now you put evaluate, it is what 3.999, that is, it is what 4. So you can check here, the value of determinant is what 4. This is what 3.99 means, what it is equal to 4. Now if we write here the previous matrix, say here 2 and 2 2 and 1 1, the value of this matrix is equal to 0. It is a singular matrix. If you try to evaluate, the value of this matrix is what 0 0. So you can evaluate determinant of matrix. Next, if A is the given matrix, A is equal to 1 2 3 4 5 6 7 8 9, and if we write print here, if you want to print here diagonal entries, then just you can write a print diagonal of DIAG by using the command DIAG of A. DIAG of A, you will get all the diagonal entries of the given matrix. So here this is the matrix. A is equal to 1 2 3 3, then 4 5 6 and 7 8 9. Okay, and if we write print DIAG of A, DIAG has no meaning. Sorry, just write np.diag, and you will get what is these are the diagonal elements of the matrix, this matrix A. So this is the first diagonal entries is 1, then 5 and 9. So you will get the diagonal entries by using np.diagonal of A. Next, if A is the given matrix, say if you want to determine the inverse of the given matrix here, say the inverse, this is what non-singular matrix, and if you want to determine inverse of this matrix, then just write down inverse of A command, and you will get the inverse of the given matrix. So here A is equal to, if we write again 2 1 1 2 1 1, then 1 2 1 1 and 2 1 1 1, and if we write here inverse of A, inv of A, and you will get singular matrix. Sorry, it is 1 1 2. It is not a singular matrix. 1 1 2, and you can see here this is what the inverse of the given matrix A. So by using this command, you can find inverse of the given matrix A. Now next, we want to determine the you can also find a trace of the given matrix A. So what is the trace? We know that. What is the trace of this matrix here? Suppose A is equal to 1 2 3 4. If we add the diagonal entries here, 1 plus 5 plus 9, we get the trace of this matrix. So it is equal to what? 15. So if we write again A is equal to here, suppose this is the matrix, and if we write here np dot, for to find a trace, just write down command np dot trace of A, and you will get The trace is what? 6. That is the first 2. This is 2 plus 2. What is the trace of this matrix? This matrix, the trace of this matrix is what? The matrix A is equal to, I am writing here, A is equal to 2 1 1 1 2 1 1 1 2. So the trace of this matrix is the addition of diagonal entries, which is equal to 2 plus 2 plus 2, which is equal to what? 6. So now next, all of we know that how to find an eigenvalue and eigenvector of a matrix. Suppose consider the 2 by 2 matrix. A is equal to, say A is equal to 3 1 2 4 3 1 2 4. This is a 2 by 2 matrix, and we want to determine eigenvalue of this matrix. Then consider the determinant A minus lambda I equal to 0. Then this implies 3 minus lambda 1 2 4 minus lambda is equal to what? 0. So if we simplify this determinant, then it is equal to 3 minus lambda into 4 minus lambda minus 2 equal to 0. So this is equal to 12 minus 3 lambda minus 4 lambda plus lambda square minus 2 is equal to 0. So this is equal to lambda square minus 7 lambda. 12 minus 2 is equal to plus 10 equal to 0. Now this is a quadratic equation in lambda. I want to determine two numbers, is that the product is 10, addition is minus 7. So such numbers are lambda minus 3, lambda minus 2, lambda minus 2, lambda minus 2, lambda minus 5 is equal to what? 0. The 5 into 2, minus 5 into minus 2 is 10, and their addition is what? 7. So it is equal to, lambda is equal to 2, lambda is equal to what? 5. So the what is the eigenvalue here? 2 and 5. So in Numpy also you can use a command EIGA to find eigenvalue of the given matrix. Say A is equal to np dot array. What is the matrix? It is equal to 3 1 2 4 3 1 2 4 3 1 2 4, and want to determine eigenvalues of this matrix. Just write down print EIG of A, and you will get the eigenvalue of the given matrix. It is what? 2 4 2 5 eigenvalues. It is a 2 5 eigenvalues, and this the next is what? Eigenvectors. So this is the first eigenvector of 2, eigenvalue of 2, and this is the second eigenvector of eigenvalue corresponding what? 5. So this way you can find eigenvalues and eigenvector of the given matrix. So next, okay, there is one more. You can find a product of two matrix by using this. Suppose A is equal to, say A is equal to 1 2 3 4, and B is equal to say 4 5 6 7. Then A dot B is equal to, that is A into B is equal to first row into first column. So this is equal to 4 plus say 12, 4 plus 12. Then first row into second column, so it is 5 plus 14. Then second row first column, so 12 plus 24, and second row second column, so this is 15 plus 27. So if we add this, it is equal to, there is 4 plus 12, it is equal to 16, then 5 plus 14 19, 12 plus 24 36, and this is 27, this is 37 plus 5 42. So the multiplication of this matrix is what? 42. Now in Numpy also you can evaluate the multiplication of matrix. So A is equal to np dot array. We are going to generate the first matrix is what? 1 2 3 4 and 4 5. 1 2 3 4. This is the first matrix. Similarly, matrix B is equal to np dot array np dot array of 4 5 4 5 6 7. So now to find product of two matrix, just write down the command. Okay, two different ways you can find a multiplication of this matrix. If you write here just print a into a dot b, you can write, then you will get a matrix say 16 19 36 and 43. So here, so you can check, sorry, 15 plus, something went wrong here, 15 plus, this is what, 15 28, here it is not 27, this is what, 28. So 28 plus 15, it is equal to what, 43. Now you can see 16 19 36 43. So 16 19 36 43. Or there is one more way, you can write it as a at the rate b, then you can use this command also to find a multiplication of two matrices. Okay, so these are the two different command. By using this you can find a matrix multiplication. So trace determinant. Hope you understood this linear algebra concept. You can solve the system of linear equation if the given matrix by using solve command. If it is a non-singular matrix, then you can find a determinant of matrix, you can find a diagonal entries, you can find a trace of the matrix, you can also find eigenvalues and eigenvector of the given matrix, and you can find a product of two matrices. Thank you.